Hey guys, this is Mrs. Gregerson, and I am kind of excited about today's lesson because it's so closely related to what we learned before when you were working with congruent triangles. Remember, if you remember our lesson from 8.2 where we introduced what similar polygons are, we know polygons are similar if their corresponding angles match up, right? Matchy, just remember. And the corresponding sides were proportional, so they had the same similarity ratio. Well, today we are going to prove triangles are similar using 3 ways. Now, remember, when we proved triangles congruent, we had 4 to 5 different ways that we could do that. Well, we're only going to have 3 with triangles and similarity. So we are going to just go and, in order, talk about those similarity postulates and theorems. We will memorize them. Their names, again, tell us what we're supposed to know. And then today we're just going to practice these. There's not a lot of these we have to do, so we're just going to practice them and make sure we really understand it. Well, the very first thing with similarity is this one. I love it. It is the angle-angle similarity. All right? So you only need 2 angles. Now, 2 pairs of congruent angles to show triangles are congruent. Now, the reason why you don't need the third is if you remember before when we had triangles, let's say that was 60, that one was 50, 60, 50, those are both 110. We know those both had to be 70, right? And I totally did not draw that scale, I know. But we knew they would have to be the same. So you only need to have 2 because if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So that's why we only ever need AA similarity. And the way we'll write that is we'll just go like this, AA similarity. So let's write this down. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So all you'll ever have to do to fulfill this theorem is to show me 2 pairs of congruent angles. And I think this is the easiest one and the most common one. This one's a postulate. This is not using really any theorems to prove it. We just know this would always have to be the case. Think about that, 30, 60, 90 triangles. Why we can actually use all those ratios always the same is because it always works. They're all similar to one another, so that's how it works. The next one, look at this one. It says the side, side, side similarity. So do I have to worry about angles at all in this case? No. We're just going to use 3 pairs of sides, but now this is where it's different than congruence. Congruence, we'd have to show 3 pairs of congruent sides. This time we're going to have to show 3 pairs of proportional sides. So we want to make sure all the ratios of the corresponding sides work. So let's write this theorem down. If the 3 sides of one triangle are proportional to the 3 corresponding sides of another triangle, then the triangles are similar. So here's what I mean by this. You would have to prove that segment AB would go with segment DE, that it would equal the same thing as BC corresponds to EF, and I'd have to show that AC would go with DF here. Notice I have 3 ratios here. I want to make sure they're all exactly the same. Again, all of these come from the same polygon on top. All those are on the bottom, same. So we'd have to show 3 pairs in this. I don't have to show any congruent angles though. And the next one I like because this is kind of familiar, kind of used to what we have. This is called the side angle side similarity. Remember we had the SAS congruence, and where does the angle have to be located? Between the 2 sides. Well, that actually happens the same way now. The angles have to be congruent between proportional sides. So you would have to show the angles are congruent, and you would have to show that segment AB is to segment DE is the same thing as BC is to EF. I could show that the sides are proportional. An example of numbers would be something like 3 to 6. We would do like 4 to 8. And I know those would have the same ratios when I was working with them. So let's write this one in. If two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then the triangles are similar. So we're going to think side angle side similarity. Okay, so what are, again, just a quick rundown, what are the three ways we can prove triangles are similar? We have the angle similarity, we have the side similarity, and then we have our side angle side similarity, and that's how you'd abbreviate those. Now, one things we want to make sure that we understand are some properties of similarity. They're kind of the same of congruence, and it kind of makes sense. The reflexive property of similarity, remember, means you can be similar to yourself. So, I mean, you're going to be the same as yourself. So your ratio would just be 1 to 1. The symmetric property of similarity means it doesn't matter which one you state first. If I say ABC is similar to DEF, then I know DEF is similar to ABC. And then we also have the transitive property. Look at this one. Remember, this is connector. This is if A equals B and B equals C, therefore we know what A equals C, right? That's like our LS, all right? So triangle ABC is similar to triangle DEF, and DEF is similar to triangle XYZ. So what do I know about these two? That they're similar. So those are just some properties that we had, and those are some common sense ones that I realized that you would probably already know. We want to make sure that we get those. All right, so again, make sure you review to yourself and you memorize for this for your quiz next week. What are the three ways that triangles are proven similar? AA similarity, side similarity, and side angle side. All right, we'll go to the next page and work on some problems.